While comparing PredictK results against production data can provide confidence in the model, achieving a better match to the production data will create a model robust enough to assist with completion optimization. In this video, I will demonstrate a couple of different methods to match the file from the adding production data to PredictK video, and provide some guidance on what kind of changes can be made while maintaining a reasonable model to obtain a match. In the adding production data video, the production data came from a decline curve. These decline curves are built on multiple assumptions that are not all true for the PredictK simulation we performed. One major assumption that does not hold true is that the flow is unrestricted. The bottom hole pressure history used for this file approximates a conservative production method. Therefore, the very early data can't really be matched without changing the bottom hole pressure history. That is not a part of the matching process, so I will instead focus on matching the cumulative production data and the late time rates. Currently, PredictK is slightly unpredicting the production from the beginning of the flow period. The easiest way to fix that is with a small change to permeability. Most permeability estimates are fairly approximate, so a 10% increase to 0.11 millidarcies can be made. Run the model, and now the two production curves are closer, but you'll notice the late time data is matched with a lack of a match early. So what I'm going to do is increase the reservoir permeability again, but decrease the drainage area. Now, run the model again. The two curves are now very close. Early time numbers are a little different, but that difference probably comes from the decline curve estimate. The match we just performed is pretty good, but I had to change a few reservoir properties that may have come from other reliable sources. By digging deeper into PredictK's features, I can achieve a match by changing numbers that probably weren't estimated elsewhere. So the first thing I'm going to do is change permeability back to 0.1 millidarcies and drainage area back to 40 acres. This time, I will work with the fluid properties to adjust the results. Double-click on the treatment, and then click on the Fluid Selection tab. The most important properties here can be accessed by clicking on the plus sign next to Fluid Properties. The key factors that can affect the fracturing fluid cleanup and production results are the cleanup rate, maximum regain permeability, and the filter cake residual percent. Maximum regain permeability will have the strongest effect, so I will change that number. The default value for this crosslink fluid was 48%. If we assume a proper breaker design was used, actual maximum cleanup could be higher. For this particular example, a value of 65% will give a good match to the artificial production data. After pressing OK to save the treatment changes, run the model. The production match is similar or slightly better than what was achieved by changing reservoir properties. To perform your own production matching, a few general principles should be kept in mind when deciding how to achieve a match. First, good initial guesses from petrophysical models, production analysis, fracture simulation, and other sources are critical for ensuring that the PredictK match represents the actual well conditions. Second, consider the accuracy of each of these data sources when determining the first variables to change. In other words, change variables that are not independently estimated first, and then move to variables where the confidence interval is large. Lastly, as a rule that applies to all matching operations, avoid changing variables if you don't understand how or why that will affect your results. Under the reservoir properties in the Well Information tab, the main variables that are changed are permeability, drainage area, aspect ratio, and reservoir pressure. The other variables would require pretty strong justification to change, or they've already been used by some of your other data sources to develop the estimates that you have for permeability and drainage area. This table gives some information about the effects you might see and how much you can adjust each of the main parameters. For the remaining inputs on the Well Information tab, fewer variables can be changed. Water rate type can be changed to make the simulated water rate closer to the rate at different parts of the production history, and improve the match during that time. Under model parameters, changing the maximum rate can force a match during restricted flow periods. Fluid properties can be changed, but they won't significantly affect the results. Closure gradient is a bit more complicated. If the source is questionable, or just provides a general range, then it can be changed and will affect the proppant conductivity. Closure gradient estimated off of reservoir pressure or treatment fracture gradient would be a good example of this type of an estimate. Increased closure gradient will decrease conductivity and therefore decrease production. As already discussed, the only remaining variables to change are fluid and fracture properties. Good estimates for some of these variables may be hard to find, so there is room for adjustment as long as physical limits are kept in mind. With this information, you should be able to start trying to match your well data with PredictK. A lot of trial and error can be involved, but with good initial estimates and care to remain within the confines of physical limits for values, reasonable matches can be made. If you have any questions, or can't figure out why a particular model isn't matching like you would expect, please contact me at steven.driley@corelab.com.